And finally, of the three sets of students, we now have three students from the University of Luxembourg, Mariusz Ludwikowski, Rod Weber, and Ray Zong joining us. Hopefully you're all on the line for your talk. Super, we can see you. Off you go. We can't hear you, mind you. We need to be able to hear you. Keep talking. No, still no sound. If you keep talking. The sound is apparently on your side where there's a technical problem. So we can't hear your sound. Switch the audio source, perhaps. What we can do is perhaps move to our next speaker and move back. Oh, try now? Yes, that sounds like this sound. If somebody could talk.
Do you hear us?
Yes, now we can hear you, but there's an echo, which can be fixed probably here. But yes, we have you. With an echo, which...
Okay.
Now we can't hear you. Try one more time, please.
Can you hear us now?
Yes, that's great. That's it.
Sorry for this audio problem here. Now here.
There is a network here.
But
Super. I think we saw a fellow supervisor there. Are you using two devices? That might be why there's feedback. Are there two devices on in that room, close by? Only one device can be open with sound.
I know that's why.
Wait, what now?
Yes.
Okay.
Yes, can you hear now? Is it better?
Is that okay for my technical team over here? Is that sound acceptable to everyone? You need to keep talking about something. How you found the last talk?
I'm sorry, we were trying to fix here the issue. We had like more than one device and it did not work properly, but starting again, I would like to thank for the opportunity, and I'm starting to present the work by me, Rod, Marius, and Rui, under the excellent supervision of Dr. Jan Tomo and Dr. Ludwig Schmidt. So if you could please put the slides on.
Yes.
Excellent. Next slide, please. Yes, next slide. And the work that we are performing is based on the original mission developed by ESA, the Mars Express mission, which was launched in 2003 towards Mars for the scientific exploration of the planet. And the goal of our study is to investigate here the costs and benefits of refueling the Mars Express spacecraft into an outpost in lunar orbit. And the method for our analysis was the use of the NASA's GMAT tool, the General Mission Analysis tool that was developed in under open source license by NASA, and we use this for the spacecraft trajectory simulation. And we have divided our work into three sections, one directly from Earth to Mars, another one launching from the Earth LEO orbit and stopping on the Moon for refueling, and then the third section departing from the Moon after refueling towards Mars. Next slide, please. In the next slide, I'll show you the computations that we have done from Earth to Mars directly. And here you can see a figure with the spaceflight trajectory from the launch date of the Mars Express, which is 2nd of June of 2003, until arrival in the 16th of December of the same year. And here you can see that we did this simulation with the goal of minimizing the velocity change in the propellant consumption of our spacecraft. And we achieved this with 15% difference margin between our simulation and the original mission. And with this direct computation, we need to validate our computational method and process in order to validate our results of the subsequent sections. And in the smaller two figures, you can also see the maneuver of Mars orbit insertion and the final orbit around Mars orbit. Next slide, please.
Thanks. Now I will talk for the Earth to the Moon part. Next slide, please. We use Gbar to do the trajectory design. You can see the light blue line shows we launched from the Earth periapsis. We did the first maneuver on 24 April to achieve the lunar periapsis of the transfer orbit. This step involved in near Earth and near Luna, those two environments. So we use Gmart to simulate two propagators to represent those two different force models. After 4 days, we did the second maneuver in order to change from the transfer orbit to our target lunar orbit, which represented by the yellow line. The yellow line looks like a spiral because it shows in Earth wheel. If you see the lunar wheel on the red top, the reference system is Lunar. This yellow line shows how we stay in this orbit for refueling. We choose a sample circular orbit around the Moon. The semi-major is 20,000 kilometers. Next slide, please. With the previous trajectory design, if we estimate our spacecraft draw mass is 817 kilograms, because it requires a large fuel tank and refueling equipments. The propellant consumptions from Earth to the Moon is 1,057 kilograms. We don't consider the consumptions for the first maneuver because it will be done by the launcher. So we can take 200 kilogram propellant, which already have more than 20% margin. Our launch mass is 1,070 kilograms because the distance from Earth to the Moon is short. Therefore, it doesn't need much fuel. So we can choose a much smaller and cheaper launcher. Then we refuel on the lunar orbit to continue the journey to Mars. Next slide, please.
Now I will be talking about the way from Moon to the Mars. Next slide, please. For the refueling on the Moon's orbit, which lasts 10 days, we slightly modified initial parameters for the spacecraft. Simulation shows that Mars Express needs much more fuel, so we increased the spaceship dry mass to 870 kilograms, which included bigger tanks and additional 75 kilograms scientific equipment. The planned maneuver list consists of the three bonds. On the 25th Mars 2003, low orbit insertion maneuver starts. 1 month later, powered flyby burns drives my spacecraft to Mars direction. Finally, Mars Express transfer has been finished on 22nd December 2003 by Mars orbit insertion burns. In fuel tanks still remains 60 kilograms of fuel. It is enough for the planned activities for the rest of the mission. Next slide, please. We are trying to answer the question, are lunar space resources beneficial? And the answer is yes, with some consideration. The biggest benefits comes directly from the Moon's orbit. It requires a smaller and cheaper launcher comparing to direct flight to Mars. We can use Falcon 9 rocket instead of Ariane 5. But there's also change for the spacecraft included. Reconfiguration of all spacecraft structures must be done. Bigger fuel consumption requires bigger tanks. Next slide, please. Additionally, it gives much more benefits from science. Additional space gives us opportunity for increase the weight of the scientific instrument of use of heavy rover. With those parameters, we can play to match mission requirements. Next slide, please. So, thank you for your attention, and we are open to answer your question.
Thank you so much, all, and I'm glad in the end we could manage to hear you for the most part. Thank you to all of the students from the University of Luxembourg. And just because of time purposes, I'm going to push on to our next speaker, if that's okay with you. But of course, you all have the opportunity to network through the course of the lobby sessions and all evening ahead.